Alright, right here we're going to run a quick summary on the nitration of benzene. So first off, we need to understand that we need to get a nitrating mixture to obtain that NO2+. So that works with concentrated sulfuric acid and nitric acid. So that is going to be H2SO4 plus HNO3 is H2O plus HSO4 negative plus NO2 plus. Okay, that's just an equation to memorize, and quite a common question is like, write the equation of the nitrating mixture. And this is what we need. This is what we use. Everything else we don't worry about, because H2SO4, just to explain this equation, H2SO4 is a stronger acid than nitric acid, so it gives off its H onto this, which is why we're left with that HSO4 negative, and then that becomes H2O and NO2 plus. So just memorize this equation as it is, and that will get you the mark for every question on write the equation to get the nitrating mixture. So nitrating mixture is right here. Okay, now for the draw the nitration of benzene with curly arrows question, which is kind of the only question that ever comes up on this. Okay, use the pencil, and so first off you have the benzene, and that's just your kind of hexagon with the delocalized pi electrons in the middle. You also have this NO2 plus species that we were talking about earlier, so I'm going to write that in there, NO2 plus. Okay, a rule for all curly arrows questions is arrows always go from negative to positive. Negative to positive. That's the direction of the arrows always. So if we identify what's negative here, it's this. It's these delocalized electrons. Okay, electrons are negative. So basically it's always electrons to the positive species. So we draw an arrow from where all these electrons are. I'll do that in my pencil color, to this positive NO2 plus species. Okay, then we draw the next stage. It's like this, same thing, except we draw this showing that the electrons have left on the NO2 plus, and the NO2 plus is now here. And because all along benzene actually has all these hydrogens on it, we're just too lazy to write them, and that's okay. You can do that for the nitration of benzene, but here we have to just show to the marker that there was actually a hydrogen here where it was added. Okay, so all of these carbons have hydrogens, but we can just save time and show, there's also a hydrogen here where we added the NO2 plus. So now it's kind of this unstable two bonds thing going on. And then, just to be clear, I like to draw this again. Just, it shows to the marker a bit more where you get the 4 marks, because usually this is a 4-mark question, rather than just kind of putting all in one step. You can still get the marks through that, but if you keep things clear, you're more likely to get those. Okay, again, it's negative to positive. There are electrons in this bond, so we give them back to that positive center because it wants to get to this stable arene ring thing. So then our final drawing is we draw this, it got its ring back, it has NO2 on it, and we do plus H plus. Okay, that will be a mark right there, because this H plus has given the electrons from its bond back, and then now it's swimming around loose. So that's your final thing, and we'd get 1 point for that, 1 point for showing positive, 1 point for H returning, and 1 point for the products. 4 out of 4. Thank you.